It's time to get started. It's time to think big, to innovate, design, and create. It's time to connect and collaborate, to find the spark that ignites the idea, so you can build, test, and deliver, so you can raise the bar and exceed expectations. You have the idea. We have the tools. So think big and change course. This is where you begin, where you design. This is mechatronics. This is SolidWorks.
Hello, welcome to the SolidWorks for Electrical Engineers 2018 launch. SolidWorks has long been a tool for designers and mechanical engineers, but we've noticed more and more that customers are not designing purely mechanical products, but mechatronics products, smart products, connected products. So SolidWorks has been expanding the ecosystem to make it easy for designers of different disciplines to collaborate. We're going to talk about some of these products today, in particular SolidWorks Electrical and SolidWorks Pcb. My name is Megan Duane. I'm a Portfolio Technical Manager at SolidWorks, and I'm here today with Lou Feinstein and Josh Moore. Lou is a Portfolio Manager for Mechatronics, ECAD, and IoT Strategy, and has previously worked in advanced technology. His goal is to infuse electrical DNA into the SolidWorks portfolio. Josh is a SolidWorks Product Portfolio Manager for the SolidWorks PCB Products and Technology. He has 20 years of experience in product marketing and management for PCB design software. So let's get started. Lou, what are some of the great capabilities in SolidWorks Electrical that our customers appreciate most?
Well, most of our customers really appreciate the mechatronics products that we've done. Now, one of our capabilities that we have is that we actually started with a blank sheet of paper and we built purpose-built products, very unique to the industry. So we started completely from the ground up making mechatronic solutions. We started with SolidWorks Electrical and then we moved to SolidWorks PCB based upon the technologies and the mechatronics type of collaboration we wanted to use. From there, one of the things that we really understand in the data management world is that customers really want to manage their data. So in the SolidWorks Electrical, we built a PDM connector that connects our enterprise PDM system to SolidWorks Electrical. It's very unique in its capabilities. It's the first of its time that allows customers to use schematics in 3D to actually drive, to manage their data.
Lou, what does that mean for our PDM managers out there? They're not familiar with electrical. Will they be able to use this tool?
Well, this tool is really specifically built for PDM managers. It's about 90% PDM, 10% electrical. We wanted to not put the burden on the electrical side and really maintain the PDM and the data integrity. One of the other things that we've really worked with SolidWorks Electrical is the startup of the product and really initially bringing the product up. It can be laborsome and laborious. So what we have done is we've created these industry templates. No matter if you're building control systems, you're building automotive, high tech, robotics, and others, we built templates that allow you to start based on industry standards, really minimizing your startup of SolidWorks Electrical.
Excellent. And the first couple sets of these industry templates are already available. You can contact your reseller for them. We have the controls and automation, both ANSI and IEC, as well as aerospace, ANSI, and IEC available. So Lou, can you tell us a bit about how SolidWorks Electrical collaborates with DraftSight?
Well, actually, we have a really great feature inside of SolidWorks Electrical that allows us to collaborate with our DraftSight tool. And what we've done is we've made it very cohesive. It's fully integrated into SolidWorks Electrical, allowing you to document and to maintain capabilities, redline, and actually show different things inside of the schematics using DraftSight. One of the things that's really unique is we actually have the ability to give customers who have DraftSight or any other 2D drafting tool electrical schematic symbols. These electrical schematic symbols in both ANSI and IEC are intelligent. So if you do use them in a standard CAD, 2D CAD product such as DraftSight, once you bring them in, and if you decide to go with SolidWorks Electrical, these intelligent symbols become alive, and your design becomes active very easily. And these symbols are available
Excellent, excellent. So can you tell us a bit about what makes our UI so special and so easy?
Well, what we try to do, and during my introduction, you talk about the fusion of DNA. What we've tried to do with SolidWorks Electrical is to infuse electrical DNA with the simplicity and the ease of use of SolidWorks. So our UI is really, really, truly based on ease of use and the user experience of SolidWorks, but with the persona for electrical engineers.
It's a lot of really great functionality. Thanks, Lou. Let's talk about SolidWorks Pcb for a little bit. It's a more recent addition to the SolidWorks ecosystem. So Josh, what are some of the advantages that these customers are seeing?
So SolidWorks PCB's biggest singular advantage is the ECAD and MCAD collaboration between both the mechanical designer and the electrical designer. SolidWorks PCB and its collaboration technology provide a seamless, intelligent, collaborative workflow and methodology to bring these two worlds together and allows the mechanical guys and the electrical guys and their counterparts to more seamlessly, more intelligently communicate, collaborate, and actually co-design these mechatronic products and these electromechanical products that they're creating. Historically, what's happened is people have relied on decades-old technology, either being STEP or DXF or IDF, to communicate and collaborate, but it's a very manual process, and a lot of times it's a very translated process if I have to basically throw a file over the wall to you and have you translate it to take advantage of the information. It's disjointed, the data's dissimilar. More fundamentally than that, even these two worlds, the mechanical world and the electrical world, are alien to each other. They don't speak the same lingo. They don't have the same design challenges. They may have competing design requirements for the products that they're creating. So the SolidWorks collaboration technology is a better way to have these two worlds communicate and collaborate together. We do this natively behind the scenes. We also do this programmatically between the two tools, so there's no exchange of data being passed through Outlook, for example, or on a shared drive. It really significantly reduces the amount of time and effort required for mechanical guys and electrical guys to communicate and collaborate as they're designing the project. They can communicate and collaborate more often. They can get things right earlier in the process, which, as you know, saves time, money, and effort as they're going through the design process.
Excellent. What about other customer benefits that they can see?
Yeah, so having both the ECAD and the MCAD worlds and designers aligned throughout the process is a clear advantage to any company whose products rely on having form and fit as part of their product design. If it doesn't fit the first time, obviously, then you've got a prototype or a respin that you have to perform, and that costs money, that costs time, it impacts project schedules. Even having designers just spend inordinate amounts of time trying to communicate or generate very large step files and push those files across a network just physically takes time, money, and effort. So by enabling this seamless design process, we cut that time significantly. It's literally a push-button process to send the ECAD data to the mechanical, or vice versa, have the mechanical guys send their data to the electrical guys for that seamless collaboration.
That's awesome. So how does this impact, or what does this mean for the individual engineer?
Yeah, so it's really, in our world, it's really both the mechanical guys and the PCB guys or the electrical engineers. When you think about a product that's being designed, an electrical product, it's not just the PCB. You don't walk into a store and just see a PCB sitting on a shelf. It goes inside of something. It's in an enclosure, it's in a case, it's in some kind of mechanical environment. So really, to create an electronic product, you have to bring these two worlds together. And for the electrical team, SolidWorks PCB provides PCB design software for schematic design, for component data management, for place and route. Also with the collaboration technology available for both the mechanical guys who are using SolidWorks Mechanical and the PCB guys. Now the mechanical guys, and one of the things we've done in the 2018 release, is really enabled this notion of the mechanical-driven design flow or mechanical-driven workflow. So now the mechanical guys can take a more active and programmatic role in communicating their intent to the electrical guys. So board outlines can be communicated with literally a push of a button. Mounting holes or cutouts or even placement requirements, placement restrictions can now be communicated intelligently and electronically throughout the design process.
Awesome. So what about SolidWorks customers that might already have Altium Designer?
Yeah, so for anybody who has Altium Designer and SolidWorks and they're struggling with their workflow and collaboration in their product creation process, Altium Designer, through their extension page, has access to SOLIDWORKS PCB connector, which everything that I just said is 100% applicable to that connector, so customers can get that and apply that to their Altium Designer environment.
Great. So both electrical and PCB are currently in use by customers in production, and they have been for some time. Lou, can you tell us a bit about how they've matured since their initial releases?
Sure. SOLIDWORKS Electrical, from its initial release, has really been driven by the customers. Actually, the creation and the conception of SOLIDWORKS Electrical was driven by our customers who have asked for a better way to collaborate between electrical and mechanical. So, following the DNA of SOLIDWORKS, we follow what our customers want. So SOLIDWORKS Electrical has been maturing based upon customer needs, but not just customer needs. What we're also, following is technology. One of the examples is that the terminal strips, terminal blocks and so forth, have now gone into what we call three-dimensional terminal blocks. Some new cutting-edge technology that allows compact density and terminal blocks. So it's new technology. So we have a lot of customers introducing us to this new technology, and we integrate these new types of technology into there, but it's our customers that really drive this. Just like any of the SOLIDWORKS products, no matter if it's SOLIDWORKS PCB or it's SOLIDWORKS or any of our products, our customers are really what give us innovation. We don't sit around thinking about what we're going to put into the product. Our customers really, really drive us. Our customers are fantastic resources to do that.
Absolutely. So why don't we take a look at one of these customers that I know Lou's talked about quite a bit. This is Sunfire. They are a leading German developer and manufacturer of clean, efficient solutions for many applications, including power and heat generation, as well as energy storage. Sunfire has been using SOLIDWORKS mechanical products since they started, and they were looking for a way to streamline work and accelerate development, and they were hoping to do this by further integrating SOLIDWORKS mechanical with electrical. So what they did is they implemented both SOLIDWORKS electrical and PDM, and what they saw were shorter design cycles, as well as they were able to eliminate redundant tasks. They were able to reduce the number of prototypes they created by 30%, because they were able to now catch issues from just the 3D models that previously they would have only found by building a physical prototype. So they were able to really reduce, they saw fewer errors overall. Excellent. So Josh, what about PCB? What's driving the evolution of the PCB product, as well as the collaboration technology?
Yeah, so I would echo a lot of what Lou said, that customers are really driving, and they're the focus of our efforts to evolve the product and technology. In our world, we don't just focus on the PCB designer or the electrical engineers. Being a collaborative workflow and having this collaborative technology, we really have to sit down with both the electrical guys and the mechanical guys to understand their workflow, understand their challenges, understand how they need or want to communicate and collaborate better, again, in order to save that time, energy, and effort in creating these mechatronic products. So when we sit down with customers, it's really a joint conversation, having both the mechanical guys and the electrical guys in the room, and it does have, it becomes interesting in some of these conversations. You get into these philosophical arguments about who owns the process. In some cases, you get into these arguments about who physically owns the hole on the board. That's come up a lot. But really, the conversation spawns a lot of thoughts and ideas about how they can collaborate better, how they can communicate better, how they can share information without going through the old way of doing things and having to use something like Outlook or shared drive, which again just takes time and effort to move data back and forth. We do it seamlessly, we do it programmatically. And once we start those conversations with customers, it really kind of gets the thought process going and how they can make it better, how they can improve the process, and how they can realize the benefits for their company. More importantly, though, we're also seeing a fundamental change in the industry. The persona of the traditional PCB layout specialist, for example, is changing. You can't go to school anymore to be a PCB person or a PCB specialist. Back in the day, you were a draftsman. You might have done PCB layout on paper, if you remember being that old. And then when computers came along, the draftsman became the CAD engineer, and then they became the PCB specialist. So a lot of these guys that have been doing PCB place and route for 20 or 30 or more years are slowly actually retiring, and they're moving out of the workforce. But they're being replaced by people who go to school to be electrical engineers or be mechatronics designers. So they have much more knowledge and know-how being an electrical engineer, trained electrical engineer, and having that background than, say, the draftsmen of the 80s and 90s. So we're really starting to see a transition to this do-it-all engineer or the mechatronics designer who wants tools and solutions to do it all. Be it the mechanical design, the place and route, the schematic, the engineering, everything that goes into creating an electronics product, again, because it's not just a printed circuit board sitting on the table. So an example, we have a customer, Laban Nuclear Technologies, and Doug, who's the president of this company, is one of these do-it-all engineers. From his perspective, he's responsible for doing the electrical engineering work, the circuit design, PCB place and route, and the mechanical enclosures that his designs have to go into. And his company specifically specializes in taking old technology out of nuclear power plants that have to be modernized, that the parts have gone obsolete, for example, and replacing it with something modern. Modern design, modern components, but it has to go back into the hole that it came out of. Quite literally go back into the hole that it came out of, because they're not redesigning the whole nuclear plant, just this one piece of it.
Excellent. So why don't we take a closer look at Laban Nuclear?
The big problem now is, simply plants will be forced to shut down, and you're not going to have electricity being produced. And a lot of times it's a very simple part that just you can't get off the shelf nowadays. Now I'm focusing on being able to supply those parts to the industry to make sure nuclear power plants stay online and they stay safe. These plants would be forced to spend a lot more money to replace entire pieces of equipment when maybe just one small power supply is broken. Maybe it's only a $1,000 part, but you're going to spend millions of dollars to put in a brand new system because that one part isn't available. This original power supply is used in a nuclear power plant. This is from the 1970s. It is obsolete, and right now it costs about $70,000 just to have it overhauled, even if that just means one capacitor. It weighs almost 30 pounds, and all the components inside are obsolete. So really, this is a high-risk power supply that plants do need, but you can't buy. This is my modern replacement that's been designed. This only weighs about 5 pounds, and it's all modern military spec components that are readily available, and this entire unit will slide in and form, fit, and function just like the original. And the plant won't even notice a difference. So getting started with SOLIDWORKS PCB was incredibly easy, just like regular SOLIDWORKS. About a day and a half after getting my license, I was able to actually completely design and send out to manufacturing a PCB. This is an LCD adapter that really just took maybe 24 hours to design. And that was the very first day I had SOLIDWORKS. This is really groundbreaking technology here, that taking old chassis and being able to put new technology into it. Right now, that's just unheard of in the industry. These two tools work automatically with each other. There's no converting, there's nothing. They just click a button and it works. One of the nicest things is that you can start on one side. You can start designing your electrical board, or you can start designing your mechanical chassis, and easily switch to the other side and easily just be able to say, yes, this works, or no, it doesn't, and make your changes, and it just updates. And being able to send that data back and forth very quickly saves you a lot of time. And when you're a small business, time is money.
That was so excellent. Well, we want to just briefly mention some of the people that we know are watching. We've got Lino, Liz, Mark, so thank you guys all for tuning in. SOLIDWORKS Electrical and PCB take mechatronics collaboration with SOLIDWORKS to the next level. You know, they make it easy to design your products from start all the way through to the finish. And it's all part of the same ecosystem, you know, the SOLIDWORKS ecosystem. It means we've got tight integration with all of the other products as well. So you can bring in PDM, you know, keep everyone on the same page. We've got SOLIDWORKS simulation. It assists with the thermal performance prediction. Visualize to get photo quality content of products from any stage of the design process. So I want to thank everyone for joining today, especially Josh and Lou. Your insight into what's new in SOLIDWORKS products for electrical engineers has been really invaluable. I know we've covered a lot today, and if you want to see more, including demos and the new ebook, the Engineer's Handbook for Designing Smart Products, go to solidworks.com/EE or talk to your local reseller. We want to thank you all for watching and joining us today, and hope you have a great rest of your day.
Multidiscipline design is now a reality when bringing products to market. Efficient, streamlined collaboration between electrical and mechanical design teams and tools is critical to ensure your product gets to market on time. Solidworks PCB delivers powerful printed circuit, schematic, and layout design capabilities. The built-in connector streamlines design change integration between EDA and mechanical teams. Changes from either discipline are tracked and incorporated in respective design tools, keeping everyone working together and in sync. The connector is also available as a standalone product for connecting Altium Designer users directly into SOLIDWORKS. Alternately, CircuitWorks delivers PCB and PWA integration to SOLIDWORKS from the majority of ECAD design tools. The simple wizard-based approach enables mechanical engineers to quickly capture the board requirements and establish a baseline for their specific fit and form. The ability to synchronize the board layout with the electronics design team ensures they have the information to complete their work and pass the final design back to SOLIDWORKS. Accurately predicting thermal performance is a critical part of electronics product development. SOLIDWORKS' comprehensive suite of thermal simulation capabilities reduce the need for costly physical testing, delivering fully integrated simulation to your design process, reducing the need for costly physical testing and risk of product failures in the field. At the same time, working in parallel, use SOLIDWORKS Electrical to generate detailed electrical schematics and define the complete electrical system. Take advantage of automated design tools and built-in libraries to streamline and simplify an array of traditionally tedious tasks. Then, integrate your electrical systems into the 3D design, at all times providing each discipline with direct access to information when they need it. As your design develops, optimization can be used to automatically route wires and cables, enabling you to validate crucial fit and wire lengths long before any prototypes are made. Regardless of engineering role or discipline, your design data must be managed. SOLIDWORKS PDM provides a single source for managing all your design data. This reduces the risk of mistakes and miscommunication and ensures everyone has access to the right information at the right time. SOLIDWORKS offers a unique and powerful collaborative solution that unites electrical, electronic, and mechanical design. Add intelligence to the mechatronic design process, enabling fast and efficient cross-discipline collaboration, providing you with the power to get complex designs to market faster.